Hi everyone and welcome to another video. So today I need to create a hydraulic manifold for a valve. It will be split in few parts, and as you can see here is the one that our customer needs, and it's size 10. So that's the final thing we want to achieve, and we need to do it from this one, which is not something standard, so there is no possibility to just buy it. If you want to create something like that, be careful about the flow. So the easiest way is to do 3 different subplates and then use hydraulic manifold that is standard, and you can buy it. It's from size 10 to size 6. So you should use metal that can hold about 250 bars. We will use this plate which I already cut. Now we just need to square it in a mill and then we can do the drilling. So I milled everything to its final size, except for one piece. It's just cleaned and the final cut can be done later, because it's long enough and it will be out of the jaws of this vise. Don't worry about the surface finish, I will grind it after I'll do everything on a mill. So first of all I will do this easy one. It's just a simple plate without any counter holes. First of all, I will just use my DRO to locate the part and drill the mounting holes. And now we can drill the holes for the fluid itself. And the part is done. I didn't even pre-drill it because it doesn't matter how the surface finish is inside of the hole. It's about the right size of the drill, and that's all. Now we can move to another one, and this one needs the milling of those two sides. And unfortunately, I couldn't find a video of me drilling holes in this one, so it's already there. But it's not done yet, we need to countersink those holes for some O-rings. And because I don't have any counter bit in this size, I just used end mill and buy O-rings for this exact size. Now we can turn it around and do the bottom part, which starts with cleaning this surface and then making the pattern that our customer has. And countersinking those holes for head of a bolt. Also, those holes, which I create on the other side, are not through the whole size of the material, it's just to the half of the thickness. And now we can drill from the other half to connect those holes and create way for the oil. I will just chamfer those holes with my drill because there should be thread to connect those two plates together. And there is the final one. This one is just for the customer's plate because we need some O-rings to seal all those manifolds together and the customers. So on this one I will do recess on both sides for some O-rings. So this pattern is same as the customers and the 1/2 that we just made. Those holes are for my customer and he will use it to mount it on his manifold that is already installed on his machine. I will just clean this surface and we can do other countersink with end mill. And for some ball heads. Now we will drill the mounting holes to connect this plate to the previous one. Now we can turn it around and countersink those holes and also clean this surface. Now we are heading to end and we need to grind all of those parts. I have this one recorded to just show you. But the surface finish isn't great. I guess the grinding wheel is not flat or something else is wrong, but for this application it will be enough. And now I just need to turn some small threaded pieces of rod to create connection with the bot part, because 10 size to 6 size manifold is always made from 10 to 6 and we need exact opposite, which is possible to make by pressing some threaded pieces to holes for the bolt head. Which you can see here on our hand hydraulic press. So now it's just time to put it all together and put everywhere those O-rings and some bolts. So that's here, and I hope you enjoyed this video, and I will see you on the next one. Bye.